Hi campers, are you ready to start day 2 of Intro to Engineering? Well, I am, and I'm really excited. Today, we're talking about simple machines. You may or may not have heard of a simple machine before, but I'm nearly positive that you've come across at least one in your life. A simple machine is a device with few or no moving parts that uses your force and motion to modify how you perform a task. There are 6 simple machines: an inclined plane, a wedge, a lever, a wheel and axle, a screw, and a pulley. An inclined plane is a sloping surface that is used to make lifting heavy bodies easier. Whenever you move an object up an inclined plane, the amount of force that you use to move the object is less than the force it would take to lift the object. An inclined plane that you've probably seen before is the wheelchair ramps that are outside of buildings. A wedge is an object that tapers to a thin edge. This simple machine increases the force applied to an object and therefore makes it easier to lift objects like a car jack, cut or split objects like an axe, and keep objects in place like a doorstop. A lever consists of a bar or board that rests on a support called a fulcrum. A downward force on one end of a lever is translated to an upward force on the other end of the lever. This can allow a small force to lift a heavy object. An excellent example of a lever is a seesaw. When you sit down on one end, it causes the other end to lift up into the air. A wheel and axle consists of a circular plane that is attached to a rod that it revolves around and is used to amplify force. You're probably thinking of a wheel and axle right now, like the wheels on a car, bike, or skateboard, but I bet you didn't know that a merry-go-round uses a wheel and axle. A screw is a cylindrical object with a plane wrapped around the cylinder in a sloping fashion. It is typically used to fasten two things together, but can also be used to modify motion. You've probably seen a wood or metal screw before around your house, but another form of a screw is a water bottle cap. The grooves in the water bottle cap fasten the cap to the grooves at the top of the bottle, keeping the cap secure and water from spilling out. A pulley is a wheel that carries some sort of flexible cord like a rope, cable, chain, or belt on its rim. A pulley can be used by itself or in combination with other pulleys to transmit energy and motion. Rotating pulleys are most commonly used to lift weights. An example of something that uses a pulley is a well, which uses one to hoist a bucket of water up. Another example is also an elevator. However, you can't see the pulleys on an elevator when you're inside of it. Now, let's test your knowledge of simple machines. Is a brick a simple machine? If you said no, you're correct. How about a doorknob? Is a doorknob a simple machine? If you said yes, you're also correct. But what kind of simple machine is a doorknob? Well, I'll give you a few seconds to think about that. A doorknob is a wheel and axle. The wheel part of the doorknob is what you actually hold and turn, the knob of the door. And the axle is actually inside the door, so you can't see it that well. But if you were to take apart the doorknob, you would be able to see it. And when you turn the wheel, you'd be able to see the axle moving as well. Is a box a simple machine? No, it isn't. But if you said yes, that's okay. It's a little bit confusing because a box does have many functions as it holds something. However, it doesn't modify your motion of force to make any task easier. Therefore, it's not a simple machine. What about a knife? Is a knife a simple machine? If you said yes, you're correct. I'll give you a couple of seconds to think about what simple machine it is, though. If you said that a knife is a wedge, then you are absolutely correct. A knife is used to split objects apart, like lettuce or carrots or anything that you're cutting, sort of like an axe. What about that rope that you use to pull your blinds up? Is that a simple machine? It is a simple machine, but what kind? I'll give you a couple of seconds to think about it. That rope on the side of your blinds that pulls them up is a pulley. The rope is attached to some wheels that pulls the blinds up. All right, campers, so today we're actually going to be making some simple machines of our own. If you're coming to the Zoom today, you can pause the video in about 10 to 15 seconds. Just make sure that you have some sort of book, tape, 2 paper or plastic cups, 2 paper plates, 1 toilet paper roll or paper towel roll, and 1 chopstick, straw, or pen. You'll also need some scissors, but for this you'll be needing your parents' help. For the first simple machine, we're making an incline plane, and you'll need a book of some sort, a heavy object like I have here, and some sort of support that you can put your incline plane on top of. For this video, I'll have 2 different supports so that I have 2 different levels that I can raise my incline plane to. So I'm going to start off by placing my incline plane on the smaller surface. Now, as you can see, if I lift up this object, it's very heavy. However, if I slide it up the incline plane, the movement is a lot easier and I'm putting a lot less work forward. So what you can do is you can take 2 objects of about the same weight, like 2 water bottles, and lift one of the objects up to the height of your incline plane, and then push the other object up the incline plane and see which one is heavier and more work. Let's see what it's like when we put our incline plane on a higher surface and raise the height. Now, what I'm going to do is I'm going to raise my object to the final height, and as you can see, it's quite a bit of work because my object is heavy. Now, if I push my object up the incline plane like this, it's a lot less work. Now, if you have 2 objects of similar weight at home, like 2 water bottles, what you can do is you can take one object and push it up your incline plane, and then take the other object and hold it up to the final height and see which one takes more work and effort. You'll notice that the object that you're pushing up the incline plane is a lot easier to push up than it is to lift up the object to the final height. You'll also notice that it's much easier to push an object up an incline plane that's raised at a lower height. This is because as the height increases, the amount of work that you put forward also increases. What you can do is you can make 2 incline planes on 2 different supporting objects with different heights and push up 2 objects with similar weight, like the 2 water bottles, and see which one takes more work and more effort. The next simple machine that we'll be making is a wheel and axle. You will need 2 paper plates, a chopstick / pen / pencil / straw. Today I'm using a chopstick because my chopsticks are a lot longer than my pencils and pens, a pair of scissors, and a roll of tape. Now, the first thing that you're going to want to do is poke a hole in the middle of both of your paper plates. Now, what you can do is you can draw a dot in the middle of your plate with a Sharpie or pen like this, and then you can have a parent or older sibling poke a hole right there with a pair of scissors. Now that you have a hole in your plate, what you're going to want to do is repeat those steps with your second plate. Now that you have 2 holes in your plates, you can see them better from this side. What you're going to do is you're going to take your pencil, pen, chopstick, or straw and push it through each one of those holes. Now this part is going to be a little hard, so I would recommend having a parent or sibling help you with this. And if you have a straw, you are going to want to make a little bit of a bigger hole. But once you have your pencil, straw, or pen through the middle, what you're going to want to do is take some tape and tape it along the edges. This will keep the plates together so that when you use your wheel and axle, they don't come apart. Once you have both of your paper plates taped together, you'll have a full wheel and axle. And what you can do is you can take your fingers and you can spin your axle, which for me is my chopstick, or you can lightly hold your axle in your hands and let your wheel glide along some sort of surface like a table. As you can see, when you spin the wheel, the axle rotates as well. And when you rotate the axle, the wheel spins with the axle. The final simple machine that we'll be building together is a lever. You will need a chopstick, pen, or pencil. I wouldn't suggest using a straw for this because you do need something a little bit sturdier than a straw. Your empty toilet paper roll. You can also use a paper towel roll and you can cut it in half. 2 plastic or paper cups and a pair of scissors. Now the first thing that we're going to be doing is we're going to take our toilet paper roll and we're going to fold it into a triangle. Now this is going to be a little bit tricky because we don't want to make any extra folds, but you can just sort of randomly choose where you want to make the folds of your triangle. And it doesn't matter if each point is spaced out evenly, as long as you just have a triangle. And as you can see, mine is a little wobbly, but that's okay. Now we're going to take our chopstick, pen, or pencil, and we're going to put it on the fulcrum. And as you can see, depending on where you put it on the fulcrum, your bar will usually fall to the side because it leans to the side with more weight. If you want, you can try to find the equilibrium of your bar and get it to balance. An easy trick to do that is to use your finger as the fulcrum until you find the equilibrium. And then once you find the equilibrium, you can place your bar back on the fulcrum. Now we're actually going to make a little bit more of an advanced lever so that you can put some load in your lever. So we're going to take our 2 cups, which will be holding the load, and we're going to mark 2 holes on the cups, about 1 inch up from the bottom of the cup. And you're going to want to do that on both sides, about 180 degrees away from each other, which is half a circle. And then once you're done with that, you're going to take your scissors and you're going to poke a hole in each side. And you're actually probably going to want to have an adult help you with this too, because it can be a little bit dangerous. Once you have 2 holes on each side, what you're going to do is you're going to take your bar and you're going to poke it through both holes, like so. This way, the bar goes all the way through your cup. And you're going to do that with your other cup as well. Now, we have a lever and fulcrum with places that you can put load in. Now what I'm going to do is I'm going to take 10 quarters and place them in each cup, and this way we will have balanced weight on both sides. And I'm going to put them on my fulcrum so that we have a full lever and fulcrum. Now your cups may lean to one side or the other, and that's okay. That's probably because you don't have your fulcrum at the equilibrium of your lever. And you know what? Most of the times, people don't have their fulcrum at the equilibrium of their lever. Sometimes what people will do is they'll have a heavy load of about 10 quarters on one side, and then on the other side, that's where they will put in their work and lift that load up. And what you can do is the same thing that I did and take off one of your cups, and you can place all your load into one cup, and your load can be anything as long as it's small and can fit in your cup, from paper clips to M&Ms or coins or candy, whatever works for you. And with just one load at the end of your lever, you'll notice that depending on where you position your fulcrum, it becomes either easier or harder to lift your load. What's actually happening here when you move the position of the fulcrum is that it gives us mechanical advantage of the lever, making it much easier for us to move the load than it would if the fulcrum were much farther away from the load. If you're super excited about simple machines and you want to go make another one that's a little more advanced, you can click the card up here and go see our video where Rosie teaches you how to make a winch, which is a hand crank machine that is used to pull objects up and uses a pulley to do so. Thank you guys so much for joining me today to learn about simple machines and Intro to Engineering. I hope that I see you either tomorrow or later on this week. Have a nice day.